Another algorithm that we've developed specifically for these rarely discharged applications is our watt-hour charge termination. Battery life is very strongly impacted by the charging voltage that's used. And so as you can see down here in this plot, as you use a higher and higher charging voltage, you get more capacity out of the cell initially, but you also end up with a much shorter lifetime on the cell. And so that if you want long life for the battery, then you can use a lower than absolutely maximum allowed charging voltage and then extend the lifetime over many more cycles, much longer in time. The watt-hour charge termination was developed specifically for systems that have a specified required amount of backup capacity that they need to supply for a system. The device will monitor the full charge capacity that is reported by the gauging algorithm, and then it automatically calculates the charging voltage that is needed and will increase that as needed in order to achieve that target capacity when charging the cell. And so then when the battery is first new and you have more capacity than you really are required to provide to the system, the charging voltage will be kept somewhat lower because that's all that's needed, and it can still provide its required backup capacity. And then as the battery is slowly aging and the capacity is decreasing, it will increase that charging voltage slightly over time in order to maintain that required capacity that's required. Of course, this means that the charging voltage is being adjusted over the lifetime, during the operation of the battery, and so you need to have some type of smart charger or other programmable charge circuitry to implement it. Here is a pictorial example of what the algorithm is basically doing. So if you were using a conventional charging approach where you just charge to full voltage, then at the very beginning of your life, you would get, for example, we've got a cell that's 3,600 milliamp hours when it's fresh. And then our requirement is that we need to have a required level of approximately 2850 milliamp hours to the system. We need to provide this amount of backup capability. And at the point to where the cell can not provide this amount of backup, then it needs to be replaced. But you want to make the cell, the system last as long as possible before you actually have to replace it. And so what happens is if you do a conventional approach, you age faster because you are charging the battery at a higher voltage than is required. And you really don't gain any benefit from charging it to 3,600 milliamp hours when all you are required to have is the 2850. And so you can see that you end up with, slowly over time, the battery will age faster and you will get below your target level, and then you need to replace the system. Another approach is you reduce the charging voltage somewhat. So instead of all the way at, say, 4.2, 4.3 volts, that's maximum allowed, you drop that back a little bit, so maybe you only charge it to 3,300 milliamp hours. And then you hold that charge voltage constant through the life of it. And so you do get more life out of the system. It lasts somewhat longer, and then you eventually will still age to the point to where you need to replace the system. But this is also somewhat inefficient in that you are also being somewhat wasteful in that you are overcharging the system more than is necessary for the required backup capacity here in the early parts of its life. And so the watt-hour charging is really trying to be as efficient as possible. It says, okay, if you only need 2850, let's only use the charging voltage to give you that 2850 and not extra beyond that. And so then it can hold that until the point where it determines that all the capacity has dropped down somewhat, and then we bump up the charging voltage. So it's back to the target capacity. And then as the battery slowly ages and you cannot provide the target capacity with that charging voltage, then it keeps bumping up the charging voltage and bumping up the charging voltage continuously until finally you end up at your maximum. And at some point then you will have aged past the point to where even at maximum charging you can sustain the required target capacity, and then so the cell needs to be replaced. But in this case you are charging it to the barest minimum level that is required based on your system specs, and so that gives you the longest life out of the battery before you need replacement. We also have a accumulated charge measurement integrated into the device specifically for these systems, and really this is just a flexible Coulomb counter that you can use at the system level. So it's measuring the charge that goes in and out of the battery and accumulating that, integrating that over time. You can program the device to integrate only discharge current or only charge current or both. You can stop it and start it when you want. You can clear it, and you can also get a measurement of the time from when you started it until it ended. So you can use this to calculate an average current over a very dynamic load, for example. We have some customers that have systems where they are only allowed to have the battery provide a certain amount of charge to a load before they then have to take some other action. And so we also have a configurable interrupt in the device. So you can set a threshold. You can clear the coulomb counter, and you can set a threshold that will alert the system when the charge that has gone out of the battery passes a particular threshold, and then the system can take further action.